कैसे हो सभी लोग? आई होप सब अच्छे होंगे। सो लेट अस गेट स्टार्टेड विद बाइनोमियल थ्योरम। आई हैव ऑलरेडी स्टार्टेड बाइनोमियल थ्योरम एंड दिस इज द लेक्चर 5th ऑफ इट। ओके, तो आप अभी तक अगर बाइनोमियल थ्योरम का प्लेलिस्ट फॉलो कर रहे होंगे तो आपको पता चल रहा होगा कि हमने ऑलरेडी बाइनोमियल थ्योरम में प्रॉपर्टीज ऑफ बाइनोमियल कोफिशिएंट एंड इसका क्वेश्चंस कैसे करते हैं, लाइक हाउ टू सॉल्व द सीरीज प्रॉब्लम्स ऑन बाइनोमियल कोफिशिएंट स्टार्ट कर चुके थे। ठीक है, तो आज का लेक्चर काफी इंपॉर्टेंट होने वाला है एंड वी विल बी टॉकिंग अबाउट बाइनोमियल कोफिशिएंट्स एंड द प्रॉब्लम्स रिलेटेड टू इट। ठीक है, तो शुरू करते हैं आज का लेक्चर। अब भी शुरू हो जाओ। ठीक है, एक कॉपी और पेन लेके बैठ जाओ और क्वेश्चंस मेरे साथ ट्राई आउट करना। ठीक है, और साथ ही साथ कॉन्सेप्ट भी रिकॉल होते जाएगा। तो शुरू करते हैं आज का लेक्चर। ओके, सो दिस इज द टुडेज गोल। वी विल टॉक अबाउट द प्रॉपर्टीज एंड द क्वेश्चंस ऑन बाइनोमियल कोफिशिएंट। ओके, तो शुरू करने से पहले लेट मी टेक अ क्विक रिकैप ऑफ व्हाट वी हैव ऑलरेडी स्टडीड। ठीक है, तो बाइनोमियल कोफिशिएंट में हम लोग ऑलरेडी क्या पढ़ चुके थे, दैट इज इन द लास्ट क्लास आई हैव टॉक्ड अबाउट कि सबसे इंपॉर्टेंट जो एक्सपेंशन होने वाला है दैट इज 1 प्लस एक्स होल रेस्ट टू द पावर n whole raised to the power n will be given as nc0 plus nc1 x plus nc2 x square। ठीक है, तो ये ऑलरेडी पता है कि हम लोग को जस्ट वेरी नॉलेज ऑफ बाइनोमियल एक्सपेंशन। ठीक है, ना व्हाई दिस पर्टिकुलर टाइप ऑफ सीरीज इज द मोस्ट इंपॉर्टेंट, क्योंकि काफी बार क्वेश्चन में क्या होगा ना कि x के जगह अगर 1 पुट कर देते हो तो आपको डायरेक्टली सम ऑफ द ऑल द बाइनोमियल कोफिशिएंट मिल जाता है, व्हिच वी हैव ऑलरेडी सीन इन द प्रीवियस डिस्कशन दैट सम ऑफ ऑल द बाइनोमियल कोफिशिएंट स्टार्टिंग फॉर r is equal to 0 to n, that is ncr is nothing but directly equal to 2 to the power n। ठीक है, 2 to the power n, तो ये हमने ऑलरेडी लास्ट क्लास में डिस्कस कर चुके थे। ठीक है, और ऑल्सो वी ऑल्सो नीड टू मैनिपुलेट। ठीक है, काफी बार क्वेश्चन में क्या होगा कि हमें मैनिपुलेट करके कि 1 प्लस एक्स की पावर n और x प्लस 1 की पावर n और दोनों को मल्टीप्लाई करके वी हैव टू बेसिकली कैंसिल आउट द टर्म्स। ठीक है, या फिर वी हैव टू जनरेट द कांस्टेंट पावर ऑफ x। ठीक है, तो ऐसा टाइप का क्वेश्चन में आपको काफी बार ये वाला टाइप का सीरीज एक्सपेंशन यूज करना पड़ेगा। ठीक है, तो without and another important thing that we have already studied is basically that is ncr is equal to the nc r minus n minus r। okay, this was one of the very important property that we have discussed in the previous lectures। okay, तो अब काम आता है कि we have to study about the properties। okay, so the very first property of the binomial coefficient is that now we have already talked about this particular property, that is in the expansion of 1 plus x की power n। okay, in the expansion of 1 plus x की power n, the coefficient of the terms equidistant from the beginning and from the end are equal। This by the basic use of this particular property, that is ncr is equal to nc n minus r। okay, so this particular property if you see, so it says that the coefficient of the terms which is equidistant from the beginning and the end are basically equal। okay, that means nc0 is equal to ncn। so if you talk about this particular coefficient, this is x to the power 0 and this is x to the power n, so both of them coefficient are similar। Similarly, x to the power 1 and x to the power n minus 1 also have the coefficient which is similar, that is nc1 and ncn minus 1। okay, so this is a very important property। okay, the next property, that is that this particular thing, that is a summation of all the binomial coefficient ranging from 0 r value ranging from 0 to n, ncr is basically equal to 2 to the power n। okay, so these are the very two important properties, okay, which we need to keep in mind। and similarly we also studied about the sum of binomial coefficient which involves the lower indices as even number or odd number is basically equal are same। okay, so if you look at this particular thing, so if you take this as even, okay, is also equal to sum of all the considering the odd parts। okay, that is c1 plus c3 plus c5। okay, and up to 2n minus 1। so if you consider this is a 2n, okay, or if you consider 2n over here, but these both are summation are equal, and these both particular summation are equal to a value which is equal to 2 to the power 2n minus 1। okay, 2 to the power 2n minus 1। I hope this particular thing is clear। okay, so this was already seen in the last particular lecture, so if you haven't watched the last particular lecture, I would request you to please go through it। okay, and the another important very important property regarding binomial coefficient is basically ncr can also be written as n by r into n minus 1 c r minus 1। so this is another very important property which we will basically use when we basically solve questions on the binomial coefficient problems involving the summation of binomial coefficient using the sigma method। okay, using the sigma method, similarly this particular can be also written in the in the format of continuous multiplication, that is in form of recursion, that is n by r into n minus r r minus r into, okay, and if you go on and you can write it like this, okay, but I don't want to write and want to expand my space, Okay, so I can write it as n minus 2 c r minus 2, and similarly this can also be expanded and you can write it up till you get that is 1. Okay, so you can do like this particular fashion. I hope this particular thing is clear. Okay, and another very important property that we already looked upon is that this, okay, is that, sorry, this is a sixth one. Okay, is that c0 minus c1 plus c2. Okay, so this is basically alternative plus minus. So if you can see, the odd one, odd lower surfaces has the minus sign preceding it. Okay, and the even one surfaces has the basically positive sign. Okay, which is basically preceding it. So if you look at this particular summation, this will basically yield you the result, which is basically minus 1 raised to the power n cn. So this particular summation, okay, this particular series sum is equal to directly equal to 0. So many times you will use this particular series summation to solve questions in just short time. Okay, so I hope these particular results are clear. Okay, now let us get started with the real questions. So I want to give you one small example like how we basically proceed questions, okay, for this particular topic. Now the very first summation, you won't be seeing this particular simple type of summation in the exam. Okay, so what type of summation you will see? So the very first question, it says that c0 c1 are all binomial coefficient or all binomial coefficients. Okay, in the of the expansion, okay, our binomial coefficient of the expansion 1 plus x power n. That means the upper one is basically n only over. Okay, so this particular thing is to be assumed whenever it is n, it is a binomial coefficient of all the expansions of 1 plus x power n. if it is written 1 plus x power 2n, then यहाँ पर इसके जगह n के जगह 2n आ जाता है. ठीक है, तो आपको जो पूछा गया दैट इज अ समेशन दैट यू आर आस्क्ड इन द कोड प्रॉब्लम इज बेसिकली c1 plus 2 times of c2 plus 3 times of c3 and so on. Okay, up to n times of cn. ठीक है, तो सबसे पहले इस पर्टिकुलर टाइप ऑफ क्वेश्चन को सॉल्व करने का जो जनरल तरीका होता है, दैट इज बेसिकली इफ यू नो नथिंग रिगार्डिंग द डिफरेंशिएशन मेथड और द इंटीग्रेशन मेथड, इफ यू नो नथिंग अबाउट दोस, जस्ट आपको क्या करना है, व्हाट इज अ जनरल अप्रोच टू सॉल्व अ सिग्मा समेशन कोड प्रॉब्लम? इट इज बेसिकली टू फर्स्ट जनरेट बाय सीइंग द सीरीज, यू टू जनरेट द जनरल टर्म. ओके, तो अगर आप इस पर्टिकुलर सीरीज को देखते हो, यू टू बेसिकली थिंक ऑफ द जनरल टर्म, एंड द जनरल टर्म लुक्स लाइक समथिंग एज आर सी आर. Okay, RC, NCR. Okay, this is a basically general term. And what is the summation? It is basically the sigma. If you vary the value of R from 1 to n, you basically get this particular series, that is the S. Okay, so how to approach this particular solution is basically we will use the concept that we studied in this particular fourth property. And if we use the fourth property, what we will see that this is nothing is equal to the sigma R is equal to, sorry, R is equal to, okay, R is equal to 1 up to n. So in place of R, you write it, in place of NCR, you write this as n by R, okay, multiplied with n minus R, n minus 1 C R minus 1. We can definitely do this by using the fourth property. So what is the advantage of doing this is that we basically cancel out this variable term, because n is not variable, only variable thing is basically R. So what we have studied in the properties, okay, what we have studied in the general series has only variable terms in this lower suffix, not multiplied with this. Okay, so what we try to do in this, basically get out the variable term, cancel out. So if we do like this, we get the R term cancel out, and this particular sigma becomes equal to n, because n is a constant, and it is basically sigma n minus 1 C R minus 1. And if you consider R is equal to 1 up to n, okay, so this will be nothing but n multiplied with, so if you put R is equal to 1, okay, you will get n minus 1 C0 plus n minus 2 n minus 1 C1, okay, and simultaneously up to n minus 1 C n minus 1. So this will be yielding you the result which we have studied in the property number first, that is basically 2 to the power n if it is NCR. Okay, similarly this will yield you the result, that is 2 to the power n minus 1. Okay, I hope this particular thing is clear. So with this, we get to the right answer, that is basically n into 2 to the power n minus 1. Okay. Now for the time being, we'll basically focus on this particular method. Now, once I particularly go on solving questions, I will basically introduce a very crucial form of a method, that is the use of differentiation in this particular binomial coefficient problem solving. Okay. So how we will do this? We will basically see in this today's lecture only, but in a later part. Okay. So let us move on with some of the recap. Okay, recap about the previous things that we have studied in form of questions. Okay, so this is the very first problem that I have on the screen. Okay, so this problem is also a problem relating the binomial coefficient. Okay, the properties also. So it says if AR is the coefficient of x raised to the power 10 minus R, Okay, in the binomial expansion of 1 plus x to the power 10. So in the binomial expansion of 1 plus x to the power 10, we have to, so AR basically denotes the coefficient of x raised to the power 10 minus r. So what we know in basically short, that whenever we have a expansion, so whenever we have an expansion like 1 plus x to the power n, and if we look the coefficient of x to the power r, that is basically directly equal to NCR. Okay. So using this particular property, what we can write about this? Okay. So using this particular property, what we can say, that AR is nothing but it is directly equal to 10 C 10 minus R. Okay. And similarly, 10C 10 minus R can also be written as 10CR. Okay. By using the property that is NCR is equal to NC n minus R. Okay. So similarly, what we have to have to find this particular question is a sigma when r ranging from 1 to 10. Okay, r ranging from 1 to 10, r cube multiplied with AR divided by AR minus 1 whole square. Okay, so if you solve this particular thing, so if you go on solving this, this is basically sigma where r is equal to 1 up to 10, r cube multiplied with AR by AR minus 1. And what is the value of AR? AR basically 10CR. Okay, and what is the value of AR minus 1? That is basically 10C R minus C R minus 1. And this is the whole square. Now, we have already studied another very important property, that is NCR divided by NC R minus 1 is equal to N minus R plus 1 whole divided by R. Okay. So this is a very important property that we have already studied. Okay. So if we use this particular property, we'll get this result as sigma r equals to 1 up to 10 r cube multiplied with 10CR by 10CR minus 1 will give you the result 10 minus r plus 1 divided by r whole square. Okay. So if you solve this, okay, if you solve this, this is basically sigma where r is equal to 1 up to 10. So if you go on solving this, this is r cube multiplied with 11, okay, 11 minus r whole square divided by r square. So if you cancel r square with r cube, it will be r only. So for this particular thing, now you basically solve this question by using the simple method that we have already that we will study, we used to study in sequence series. Okay, so this will give you the sigma r is equal to 1 up to 10, that is r into 11 minus r ka whole square. And since we know the expansion of 11 minus r ka whole square, this can be directly written as 121 minus, okay, minus 22r, okay, plus r square. And if you expand this again, this sigma r is equal to 1 up to 10, this will be 121r, okay, minus 22r square plus r cube. And if you use the general result that we studied, that is sigma r is equal to n into n plus 1 by 2 if r belongs from 1 to n. Similarly, sigma r equal to 1 to n, r square is equal to n into n plus 1 into 2n plus 1 whole divided by 6. Okay. Similarly, sigma r equal to 1 up to n, r cube is equal to n into n plus 1 divided by 2 ka whole square. Okay, so this is the very important result that you must keep in mind. Okay, so if you use this particular result for this particular problem, you will directly get to the result which is equal to 1210, because I have solved in my rough. Okay, so you also please solve this particular problem in your rough and verify the answer. Okay, so with this you will get to the right answer of this particular problem is option number D. Okay, so this was also a JEE main problem which came in the year 2023. Okay, so this is the option, this right option is option number D. I hope you are clear with this particular problem. This is a very, very simple problem. Okay, so let us move further and let us try out another very important type of problem. Okay, now before trying out this particular problem, I would like to again we have to basically remember that particular property, that is NC R is equal to NC n minus R. Okay, NC n minus R. So if you see this expansion, this is the sigma r equal to 0 up to 22, 22 CR, 23 CR. Okay. So if you look at this particular expansion, that is r equal to 0 up to 22, 22 CR. So you can write this particular thing as 22 CR, and this particular 23 CR can also be written as 23 C, 23 C minus R. Okay, so what is the advantage of writing like this? Okay, so this is a very important step that you must remember, because many in time questions won't be involving a single binomial, it will involve the product of binomial coefficient. Since I have taken out this question very early, okay, so I'm here to basically explain you the procedure, like how to approach this particular problem. You don't have to take this particular problem as a challenge. Okay, first learn it, and later also we will solve problems regarding product of binomial coefficient, summation involving product of binomial coefficient. Okay, but I took this particular problem just to give you an idea, like how to approach this particular problem, like get an intuition beforehand only. Okay, so if you look at this particular problem, so what we can write is that, okay, so if you know that the expansion of 1 plus x to the power 22 can be directly written as c0 plus c1x plus c2 x square and so on up to c22 x to the power 22. Okay, so we can write like this. Similarly, 1 plus x raised to the power 23, but instead of 1 plus x raised to the power 23, we can do one important thing, that is basically, in place of 1 plus x to the power 23, I want to write it as something as x plus 1 to the power 23, and if you do so, you will get it c0 x to the power 23 plus c1 x to the power 22 and so on up to c23. Okay, into x to the power 0. Okay, now what I want to do is this particular problem is that, now whenever, in order to get the coefficient, what is the summation of this particular thing? The summation part, if you look at the summation part, okay, so if you look at the summation part, this is basically 22c0 and 23c23 plus 22c1 23c22 and so on up to. Okay, so what we can observe over here is that if you and in this particular series, what correlation we can observe, that if you multiply this both the series such a fashion that in multiplying this particular expansion and then take the coefficient of, and then take the, okay, okay, my fault. Okay, I didn't want, in this particular problem you don't need to like cross multiply and write, because there it involves problems. Okay, because there are some problems which basically involves like you have to you have to exchange this particular terms and then multiply. But in this particular problem you don't need to basically, because what I need to generate is basically this particular term, and this particular term will generate as a coefficient of some particular number. Okay, so how to do that? Instead of writing x plus 1, I will again take my word backs and I will write it as 1 plus x. So in doing so, what I will get is that, so see, I am trying it out so that I can understand. So this is the step that you basically need to apply in exam also, so that you basically get out like what thing we need to try it out. Okay, so after doing this particular thing, now if you multiply this particular expansion and then look for the coefficient of x to the power 23, okay, then look for the coefficient of x to the power 23. What will you get? So if you multiply these both the terms, so you will, for x to the power 23, the term involving will be c0 multiplied by c23. Okay, similarly there will be term c22 into x to the power 22, and if you multiply this particular term c1x into c22 into x to the power 22, you will generate the term which is basically c1 into c22. Okay, this is basically 23 c22. Okay, 23 c22, and this is basically 22. Okay, 22 c1 22 c2. Okay, so you will get this particular term, that is 22 c1 into 23 c22. Okay, which is basically nothing but the coefficient of x to the power 23 in the expansion of 1 plus x to the power 22 multiplied with 1 plus x to the power 23. So what I want to write is basically this particular summation. If I represent this particular summation by a number or by s, okay, so what I can see, what I can write over here, that s is the coefficient of, okay, x to the power 23 in the expansion of 1 plus x to the power 22 multiplied with 1 plus x to the power 23. Okay, so if you multiply these both the terms together and then take the coefficient of x to the power 23, you'll basically end up getting this particular summation, that is the summation terms. Okay, the sum of all the terms which is involved in the summation s. So what we can see from here is that this is nothing but 1 plus x to the power 45. So in 1 plus x to the power 45, if we need to look for coefficient of x to the power 23, this result directly gives you 45c23. Okay, I hope this particular result is clear. It's very clear. It must be very clear. Okay. Now we will basically solve lot of questions involving product of binomial coefficient and the summation of it. Okay, so stay tuned for that in the upcoming lecture. But I took this particular problem just to give you an idea, like these problems are not very tough. You just basically have to have an intuition regarding solving these particular problems. Okay, so what is the intuition? Is basically you take the two series and then cross multiply it, or you take the product of the two series and then take the coefficient of that particular x keep raised to the power some power, and of that power you'll basically get to the result of which is a single binomial coefficient. Okay, and the answer to this particular problem is option number B. Okay, so I hope you have got this particular problem. Okay, so very important problem. Okay, so let us move further and let us try out some of the other problems also. Okay, so let us move further and let us learn some of the example. Now this is a very important example that I want to teach you, because in this particular problem I will solve this particular problem by like two or three different methods. Okay, two or three different methods. Okay, so the very problem says that C0, C1 are basically binomial coefficient of the expansion 1 plus x to the power n. So in the most of the problem up till from now, you'll basically see the expansion of 1 raised to the power n. Okay, so the summation that is asked in the problem is basically C0 plus 1 times of, sorry, 2 times of C1 plus 3 times of C2 and so on up to n plus 1 times of Cn. Okay, now these are very pretty simple type of problem. Okay, because you are knowing with the general term of this particular problem. So the very first task of this particular problem is to generate the general term, So what we can see from here, the general term of this particular problem is basically r plus 1 into CR, okay, or NCR to be very specific. Okay, now how to solve this particular problem? Okay, now in order to solve this particular problem, what we can do, what we can try out is that, so what is the summation S? It is basically sum of all the general term that is ranging from r is equal to 0 up to n, that is r plus 1 multiplied with NCR. Okay, so if you see this particular problem, this problem is again a simple problem, that is sigma r is equal to 0 up to n into r into, so if you take the, if you open this particular bracket, this will be r into NCR plus sigma, and using the property of the sigma, that is it is distributed over the sum addition or subtraction. So we can do like this. This is basically r is equal to n to 0 to n. This is basically NCR. And we have already studied that n into NCR is nothing but n into 2 to the power n minus 1 plus, and this particular result yield you 2 to the power n. So if you combine this, you will get the result as 2 to the power n minus 1. If you take common, this will be n in n plus 2. Okay, so this is the result of this particular summation is 2 to the power n minus 1 into n plus 2. Okay, so this is a very fast method, okay, that I wanted to discuss. Now the very important method that I want to discuss is basically the use of differentiation method. Okay, so how to solve this particular problem? The same problem, that is a summation, that is summation of C0 plus 2 into C1 plus 3 into C2 so on up to n plus 1 into Cn. Okay, so this is a method that I want to use, because not every time you will be basically using the general term method, because general term method also has some limitation, because you need to think and how to eliminate the variable parameter. Okay, but instead if you use the differentiation method, it will be way more easier to solve problem, because you just have to think and generate the expansion. That's the only point of thinking that you need to do, and then take the differentiation and use that particular result. So how to solve this particular problem is that, so if you see of this particular term, if you see this, the lower suffix, that is 1, and the term which is multiplied to it is basically 1 plus some 1 plus that particular lower suffix. Okay, so how to generate this particular thing? So what I approach, I think as a first time when I particular solve this particular problem is, firstly let us take the use of this particular general expansion, that is C0 plus C1x and so on up to, okay, Cn x to the power n. Okay, so this is a general idea that I want to use. Now why I want to use this particular idea? Because many a times if you differentiate this particular problem to generate the resultant output and then put the value of x is equal to 0 or x is equal to 1 to generate the corresponding results. Okay, so what I try to see is basically I need, if I differentiate this particular term, so I'm just trying it out. Okay, I'm just trying it out in order to explain you like why to do this, why not to do that. Okay, so that is a problem that you must be wondering in your mind. Okay, so why we basically approach a particular problem in a particular fashion only. Okay, so that particular problem has an answer. So let us try it out. Okay, let us hit and try. Okay, so if I want to use the differentiation method, so if I differentiate this particular to both the sides, so I will left out with the term that is n into 1 plus s ki power n minus 1 into differentiation of x, that is 1. Okay, and is equal to, if I differentiate this is constant, is 0. Similarly, differentiation of this is c1 plus c2x, and we know that c2 x square, so this will be 2 times of c2x, because the differentiation of or d by dx of x raised to the power n. So this is a very simple formula that you must remember, because we have studied this particular formula from physics only, that is equal to n into x ki power n minus 1. Okay, where n is basically an integral quantity. Okay, so using this particular result, what we can see, this will plus 3 times of nc3, okay, c3 x square, and so on up to n into ncn x ki power n minus 1. Now in place of x is equal to, if you put x is equal to 1, what summation you will approach? The summation you will get is basically c1 plus 2c2 plus 3c3 and so on up to ncn. Okay, and this will be is equal to n into 2 to the power n minus 1. Okay, and this was a summation that we basically found out by using the general term method in the previous to previous example, and that was basically sum of all the binomial coefficient ranging from r is equal to 1 up to n, r into ncr. Okay, but in this particular problem we don't need to have to get this. Okay, so what we need to get this is we have to keep this particular constant term, that is c0, because we need the c0 term in the summation method. So what thinking I can develop is that let us first multiply that particular expansion, that is 1 plus x power n, with an x, so that I generate the result as c0x plus c1x square and so on up to cn x power n minus 1. And in doing so, what I get after differentiating this particular parameter is basically, that is n into 1 plus x power n into x, plus we will basically use the by part method. And if you don't know what is a by parts, okay, sorry, product rule, that is differentiation of u into v, where both u and v are basically function of x, is basically u into differentiation of v minus, sorry, plus v into differentiation of u. Okay, so this is the product rule of differentiation. Okay, so if you use this, you will get it n into 1 plus x power n a into x plus 1 plus x power n. Okay, and this result will give you, the result is that when you differentiate this, you will have the result c0 plus 2 times of c1. And what is the advantage you will get? You basically get the advantage, that is what is the lower suffix is present, the term multiplied to that particular binomial coefficient is 1 plus that lower suffix. Okay, so that was what we needed in this particular problem. Now if you go on, and this will be basically yielding you the result n plus 1 into cn. Okay, and this is nothing but the summation you need by putting x is equal to 1. So in place of x is equal to 1, if you put x is equal to 1, you will basically get to the summation at x is equal to 1. So if you put x is equal to 1, the summation value will become 2 to the power, sorry, this will be n minus 1. So this will be 2 to the power n minus 1 into n plus 2 to the power n. Okay, so this particular result will give you the result, that is 2 to the power n minus 1 into n plus 2 into n plus 2, and this is the value of the summation s. Okay, so this is the method that we basically use to solve this particular problem, and this method is known as the differentiation method. This method is known as the differentiation method, and this is the second method. Okay, now we'll solve many problems, okay, by using the differentiation method, so as to get an understanding like how to solve these particular problems. Okay, so I will take a lot of examples to illustrate whatever I teach in this particular this video lecture. Okay, so let us get started with another important example. Okay, so the next example that I wanted to take up is another very important example, and I wanted all of you to pause this particular video, just try it for this particular problem. Okay, so let me write the problem. So the problem, again, statement same statement, that is c0, c1, c2 up to cn are basically binomial coefficient of the expansion of the term 1 plus x power n. Okay, so if you look at what summation we need is basically c0 plus 3 times of c1 plus 5 times of c2, okay, and so on up to 2n plus 1. Okay, so I am giving you everything, 2n plus 1 cn. Okay, so how to solve this particular problem? So I would request you just pause this particular lecture in this particular moment only and try it out. Okay, so once you try it out, you will basically understand like how to approach this particular problem on yourself, and then only you will feel like which method is comfortable for you to solve the problems in the exam point of view. because I will solve this particular problem in both the methods, the differentiation method as well as the that summation general term method or the summation method. So let us solve this by the general term method. Okay, so let me write it, the general term of this particular series. So if you look at the general term of this particular series, it is basically 2 times of r plus 1 multiplied with NCR. Okay, so if you look at this general term of this particular series, it is basically 2r plus 1 multiplied with NCR. Okay, so what is the summation that is asked is basically sigma r equals to 0 up to n 2r plus 1 multiplied with NCR. Okay, now to solve this particular by the sigma method, we basically open this bracket, that is sigma r is equal to 0 up to n, that is 2 times of r into NCR plus sigma r is equal to 0 up to n NCR. Okay, and we know the value of NCR is basically 2 to the power n, and we know that any constant multiplied with the sigma sign comes out of the sigma, so this can be written as 2 multiplied with sigma of r into NCR, and we have already seen the sigma of r into NCR is basically n into 2 to the power n minus 1. Now you must remember this particular result. This is also a very important result that you will be using in most of the problems, so better to keep it remembered. Okay, so this will be equal to n into 2 to the power n minus 1 plus 2 to the power n. So if you look this will become 2 to the power n. If you take common, because if you multiply 2 to the power n with 2 to the power n minus 1, it will be 2 to the power n. So this will become 2 to the power n into n plus 1. So the summation that you are looking in the problem is basically 2 to the power n into n plus 1. 2 to the power n into n plus 1. Okay, so that is the right answer. Now let us try to solve this particular problem by the differentiation method. So in order to solve this particular problem by differentiation method, can you do that? Okay, now think about, I would request you to like just think about, give a thought about it, like how will we solve this particular by the differentiation method. Okay, so if you look at this, okay, let me talk about the differentiation method, because many times you have to do a mathematical jugglery, okay, between like which method you have to apply to get the result quickly. Because what you see in this particular, for this types of problem where you basically comfortable with the general term, you use the general term method and you will directly get to the result because you remember the results clearly. Okay, but many in time the results are not very simple, that is basically asked in the problem or the exam point of view. So for that purpose you basically use the differentiation method. So that is the kind of mathematical jugglery that I wanted to request from all of you, and that comes only with practice. Okay, and a good point is that in the description box of the today's video you will basically find the like lot of problem statement attached. Okay, so I would request you just try those problem statement, and once you are done trying those problem statement, just write in the comment section, okay, that I have done it. Okay, so that I will get the understanding like whether are you solving it or not. Okay, like I need to get an understanding like these videos are either helpful or not, or what things I need to make changes in these particular videos. Okay, so that it is more beneficial to all of you students. Okay, so let us start with the differential method or the second problem. So what summation we need is basically C0 plus 3 times of C1 plus 5 times of C2 and so on up to. That is the basic summation is. So again we will start our approach from this particular expansion, that is 1 plus x power n. So what we see, that is C0 plus C1x plus C2 x square up to so on up to Cn up to x power n. Okay. Now, in order to get 3 over here, that is 1, and if you look at the lower surface, it is plus 2, and if you look at this lower surface, it is plus 3, and similarly, it will go on increasing because it is a variable, because this is an odd number coming up. Okay, so in order to get this particular thing, what I can do, I can multiply this particular term with x square. So if I multiply this particular term with x square, okay, if I multiply this particular term with x square, I will get x cube, and I will get x power 5. Okay, so it is not very favorable to like go with that particular method of differentiation, because if you are not getting any particular term, because the differentiation method only applies, see, listen, there is a very important catch, like why to use a differentiation method and why not to use a differentiation method. So if you look at this particular, because I wanted to say, because I'm going to look and hit and try like whether I can apply or not. So this is a learning that you must take from this today's lecture, that not everywhere we can apply the differentiation method, also not everywhere we can apply the general sigma method. Okay, So the limitations are basically, this is a particular type of limitation that you can face. That is basically why you don't have these particular terms, or after differentiating the terms are not basically coming as constant. But we can try out, like what we were trying out, we are taking it x square, and then we were taking x square over here, this will be x cube, this will be x cube by 4, okay, and similarly this will be n plus 1, and then again differentiating it, okay, and then again multiplying with. So this becomes a tedious process also, okay. So it is not like that you cannot, you just give a thought, okay, like how we will basically get, or maybe you can come up with it. So this is a problem that you basically encounter, that not to use the differential method whenever you basically encounter variable times of like coefficient over here, which you cannot generate from the differentiation method. So it is better to go with the sigma method, okay. So these are very important understanding that you got from today's particular these things, okay. Now let us move further and take up one another important problem, okay. Because this particular today's lecture has no much of a theory, but what is had is much of understanding of how to solve problems, okay. Now the next problem that I want to take up is a problem again which involves a binomial product, okay. So again it is saying the same thing, that is c0 c1 are all the binomial coefficients of the expansion of the term 1 plus x to the power n, okay. So and the summation that is given in the problem is basically 1 square into c1 plus 2 square into c2 plus 3 square, okay, all the terms square is given, plus c3 into c3 up to n square cn, okay. So the very first thing we can do is basically get to the general term. The first method that we have to solve this particular problem is by the general term method, okay. I will solve this particular problem by binomial method, differentiation method, okay. You can also try it out by the differentiation method as well, okay. So you can do it on your own, okay, just go on and do. Okay, so the general term what we can see is basically this r square into NCR. Okay, this r square into NCR. So the summation that is asked in the problem is basically sigma r is equal to 0 up to n. Okay, sorry, instead of 0 it is given. Also it doesn't matter, because if you put 0 or if you doesn't put 0, doesn't matter. Okay, this will be r is equal to 1 up to n. Okay, this is r square multiplied with nc r. Okay, so in order to solve this particular problem, what method I basically imply is that I can write r square something as r into r minus 1 plus of r. Okay, now why to do this particular this trick? Okay, why to do this particular trick? Because we do not know any result which directly involves r square into NCR. Okay, so instead of doing like that, we basically multiply it with r into r minus 1 plus r, because what we can do, you can generate this particular term and then cancel out the variable terms and then get a simpler result. So that's what our idea is to solve this particular problem by. So if you write in place of r square, if you write in place of r square, if you write this as r into r minus 1 plus r whole multiplied with NCR. Now we open the bracket and we can write this particular sigma as r is equal to 1 up to n r into r minus 1 into NCR plus sigma r is equal to 1 up to n r into CR NCR. Okay, so what we can see, that the summation is basically sigma r is equal to 1 up to n, okay, r into NCR plus sigma r is equal to 1 up to n r into r minus 1 CR. So we already know this particular result, that is r into NCR is directly equal to how much? We have studied this r into NCR. Okay, in this particular result, r into NCR is n into 2 to the power n minus 1. Okay, so this will be a result giving us n into 2 to the power n minus 1 plus, and this particular result we can also solve this by using the properties, that is r into r minus 1, and instead of NCR we can write this as n into n by r multiplied with n minus r n minus 1 divided by r minus 1 multiplied with n minus 2 c r minus 2. Okay, by simply using the result that we studied in the properties. So what is the advantage of doing this is that the variable term get cancelled out. This is the r get cancelled out with r minus 1 get cancelled out. So we are left with the result, that is n into 2 to the power n minus 1 plus, and for this, that n into n minus 1 is basically a constant that comes out, and that is n into n minus 1 sigma r is equal to 1 up to n. This will become n minus 2 c r minus 2. Okay, this is n minus 2, c r minus 2. So in place of r, if you put, so instead of r is equal to 1, we started with r is equal to 2. Okay, that will be an advantage, because not an advantage, we cannot take r is equal to minus, because this coefficient, lower coefficient of binomial coefficient cannot have, the lower suffix cannot have basically negative term involving it. So we have to basically start our sigma, because the r is equal to 1 has nothing, no implications, because, and this is the very important catch that you must remember, because when you are reducing the terms, you just have to take care what is the value of r over here. Okay, so in place of, when you look at this, if you put r is equal to 1, it will generate you the negative result. Okay, which is not possible, so you have to start this summation from r is equal to 2 up to n. Okay, so what we get is that this particular result is again very familiar to us. This is nothing but n 2 to the power n minus 2, and then the finally the summation becomes n into 2 to the power n minus 1 plus n into n minus 1 into 2 to the power n minus 2. So if you take 2 to the power n minus 2 as common, okay, if you take 2 to the power n minus 2 as common, you will get 2n plus n square minus n. So n square minus n plus 2n square will give you the result, that is plus of n. Okay, so the result you will get in this particular problem is equal to 2 to the power n minus 2 into n plus 1 into n plus 1, and that is the value of the summation s. Okay, that is the value of summation s. Okay, I hope this particular problem or the result is clear. All right, so now let us solve the same problem by the differentiation method. Okay, now let us solve this same problem by the differentiation method. Will basically yield the same result, but you will see that it basically reduces the number of steps. Only thing is basically you have to think. So the summation that we are getting, that is n square cr sigma r is equal to 1 up to n. Okay, so we will start our journey by this 1 plus x power n is equal to c0 plus c1x so on up to cn x power n. So in order to generate the r square over here, what I need to do? Okay, in order to generate r square over here, what I need to do? Okay, so if you look at, you multiply with, okay, so if you multiply with, like firstly you multiplied with x. Okay, now what is the advantage if you multiply with x? So if you look at the advantage of multiplying with x, okay, or instead not multiplying with x, because we don't need the term c0 over here. Okay, so what I can look about is basically, firstly let us take the differentiation of this particular term. Let us take the differentiation of this. So if you differentiate this result, you will get as n into x power n minus 1, and the result you will left with c1 and so on up to cn x power n minus 1 into n. Okay, now from here, let us again, and this will be 1 into, so from here let us again multiply with x. Okay, so let us multiply this particular differentiated value with an x. Okay, so if you do this, you will get x over here, and similarly you will have 2 over here. Similarly this will get x again, x square again. Similarly if you multiply the x again, this will plus 1, so this will become x power n again. So what we do, once again differentiation, after differentiating we again multiply with x. So firstly you differentiate and then multiply with x. Okay, and then multiply with x, and so this result, and if again you differentiate it, if again after multiplying with x, if you again go on differentiating it, so you will get the result as x into n minus 1 into 1 plus x t power 1 plus x t power n minus 2 plus n into 1 plus x t power n minus 1, and this is equal to, see if you differentiate this result you will get 1 into 1, that is 1 square c1 plus 2 into 2, that is 2 square c2, and so on up to n into n, that is basically n square. Okay, n square cn, and that is the required summation that we need when if you put x is equal to 1. So this reduces, so what you can see, the differentiation method reduces the number of steps. So only thing is that you have to basically think like which factor of x you should multiply in order to generate that particular summation, and then differentiate it, and again multiply, again differentiate it in order to get the in order to get the desired result. Okay, so if you put x is equal to 1, you will get the same result, that is n into n minus 1 2 to the power n minus 2 plus n into 2 to the power n minus 1, and that result if you simplify, it will give you the result as 2 to the power n minus 1 into n plus 1. Okay, I hope this particular result is clear. Now very simple result. So what I want all of you is to try. Okay, now before moving on this, okay, let us, because this involves the product of binomial. Okay, because I also wanted to teach upon the product of binomial. Okay, we have already seen the idea like how to take the product of binomial and then multiply it with the differential method. So that's what the question is desiring. Okay, but before solving it, I want to give you one small example, like example homework. Okay, so if you take this, these are the homework that I wanted to give in today's lecture, because the next lecture I will start out with discussing these particular problems only. Okay, so the another homework, that example that I want to give you to try is again a problem that is a summation of 1 cube C1 plus 2 cube C2 and so on up to n cube Cn, where C1 C0 and all the C1, okay, C0 and Cn are all the binomial coefficient of 1 plus x raised to the power n. Okay, so what I want is basically the value of x s. Okay, so just calculate the value of s. If you are not able to see this particular problem, I will write it over here. Okay, the fourth problem is basically you have to take the summation of 1 cube C1 plus 2 cube C2 and so on up to n cube Cn. Okay, now solve this particular problem by both the methods and then cross verify the result. Okay, both the methods, I mean to say the general method as well as the what is called the differential method. Now how to solve this by general method, because if you will get the term as r cube, so in order to simplify the r cube term, you can do like this. It is basically the multiplication, okay, r into r plus 1, or sorry, r into r minus 1 into r minus 2, and then add the terms which you basically subtract. So what you subtract is basically so if you look at the term, the r cube term is there, so the extra terms are if you multiply the extra terms, what do you see? The extra terms you have to basically subtract, okay, and add also. Okay, so add and subtract the extra terms. How will you know the extra terms? You basically solve this expansion, and then you will see the extra term, then subtract it or add it the extra terms, as you can see. Okay, so that is what the method that demands. Okay, so this is another important homework problem. Okay, I hope you will try this particular homework problem, and before the next lecture you'll basically come up with the problem solution also, and you will mention in that comment box, okay, of the today's lecture. So I'm hoping that you will basically solve this particular problem, otherwise you won't be able to understand this particular lectures. Okay, so that is a very serious note from my side. Okay, all right. So let us try out this vertical problem. Okay. Now before solving this problem, what you can see is this problem basically involves square of the binomial terms. Okay, square of the binomial coefficients. And the square of the binomial coefficient is basically generated by a concept that we already have seen before starting the summation problems. Okay, that is basically the problem that we have looked forward in the before the today's class only. Okay, that is a problem involving 22 CR multiplied by 23 CR and summation where r is equal to 1 up to 23. The result, we have already seen that particular problem. Okay, sorry, r is equal to 1 up to 22 it was going. Similarly, this problem also will go like that. So before solving this, let us get an idea like how to get this problem. So the very first example, that the very first starting point will be 1 plus x to the power 30. Why 30? Because the highest power, that this the upper suffix is 30 over here. So if I take 1 plus x to the power 30, this will give me the result 30c0 plus 30c1 x and so on up to 30c 30 x to the power 30. Okay, now let us differentiate this particular result. Okay, let us differentiate this particular result and then write it over here. So if I differentiate, this will be 30 into 1 plus x to the power 29, 1 plus x to the power 29, and this result you will get it as, okay. So if you get this result, you'll get this result as like if the first time will vanish, and this will be 30 c1 and so on up to 30 into 30 c 30. Okay, now again multiply this particular term with x. So if you multiply this particular term with x, that is 30x plus into 1 plus x to the power 29, okay, is equal to 30c1x and so on up to 30c, sorry, this will be x to the power 29. So this will become 30 into 30c 30 x to the power 30 over here again, okay, because I multiplied with x again. So in doing so, this is the second result and this is the first result. So what I want to get in the summation, if you look at the summation demand is as 30c1 whole square plus 2 times of 30c2 whole square and so on up to 30 times of 30c30 whole square. Okay, now how to get these product terms with along with 2 over here? So what you can look, if you multiply the first expansion and the second expansion, so if you multiply the first expansion and the second expansion, and then you look for the like you need to get the 30C1. So and then you look for the, and then if you multiply this particular term, the 30C1 and 30C1, okay, okay, so if you multiply this 30C1, 30C1, so you will basically get 30C1 whole square. But what we need to have come to a conclusion what the coefficient of this particular binomial coefficient or the recurrent binomial coefficient in the summation should be a constant. That is a power of the x should be a constant, so that it is easy to generate that particular coefficient. So instead of writing this particular thing, we will basically reverse it and write the same. Okay, this particular second expansion, I will reverse it. I will just reverse it. Okay, instead of writing 30x x 1 plus x by 29, I will write it as x plus 1 by 29. The only thing it will reverse is basically in place of 30C1, in place of x, it will come 30C1. Okay, so no, I am very sorry. Okay, there will be a problem. Okay, so instead of doing, let us start from the beginning only. Okay, that is reverse the term. That is reverse the term. That is 1 plus x ki power. Okay, 1 plus x ki power um, 30 only. Okay, so if you do this 1 plus x by 30, I will get is 30C0 plus 30C1 x and so on up to 30C 30 x ki power 30. So let us number this as third particular expansion. So if I multiply, now what we need to look for is basically 30C1 and 30C1. Okay, so if you look at this particular expansion, so if you take, okay, sorry, very sorry, my fault. Okay, this will become no, this from here the first term will become x ki power 30. Okay, this will become instead of 29 and this will become 1. Okay, now what we can see, now in order to get 30C1 and 30C1 multiply, what you can see that this second expansion and the third expansion you multiply, and if you look at the coefficient of x ki power 30, or if you look at the coefficient of x ki power 30, so okay, now how we are getting the coefficient of x ki power 30? So if you multiply this particular term with this term, okay, with this particular term, then you get 30C1 whole square. Okay, along with 1 over here. Similarly, what the next term is over here is present. Okay, along with the next term which is present over here is basically 2 into 30C 2 x square. Okay, so if you multiply 2 into 30C2 x square with the second term which is present over here, okay, with the second term which is present over, that is 30C2 x ki power 28, you will again get the coefficient of x ki power 30. That means if you multiply, that means the summation that you basically denote is the coefficient of x ki power 30 in the expansion of 30 into x into 1 plus x ki power 29 into x plus 1 ki power 30. Okay, so s is the summation that is required in this particular problem is nothing but the expansion is basically the coefficient of x ki power 30 in this particular expansion. So if you look at this particular expansion, this is 30 into x into 1 plus x ki power 49. Okay, so 1 plus x ki power 49. So if you have to get the coefficient of x ki power 30, we basically have to, from here we have to look for the x ki power coefficient of x ki power 29, and that is basically the answer is 30C 49 C29. 30 into 49 C29. Okay, that is a coefficient of x ki power 30 in it. Okay, I hope this particular result is clear. Okay, so from here, okay, so the summation that is basically asking the problem. So again, I repeat my words. Okay, so how we are basically doing it? We multiplying the expansion third and the expansion second, and then we basically what we see that the coefficient of x power 30 is a result. The coefficient of x power 30 in the expansion of this particular expansion is the required summation that you need in this particular problem, and the result comes out as 30 into 49 C29. Okay, 30 into 49 C29, and this particular result is given as in the problem is given as 60 alpha into 60 factorial. Okay, very sorry my side. Okay, calculation mistake, this will be 59. Okay, very sorry from my side, and this is given as 30 into 59 C. Okay, this will be 59. Okay, 59 C 29, and this is given as alpha into 60 factorial divided by 30 factorial. Okay, so what is the value of alpha? Okay, so what I do is that I multiply with 29 very sorry, So what I do, I multiply and divide with a term which is 60 by 30, again divide by 30 by 6 or multiply with 30 by 60, so that that term nullifies out and it is 1. So what is the advantage of doing so is that if you look at this particular thing gives you the feeling of the coefficient term, that is n by r into n minus 1 cr minus 1 is equal to ncr. Okay, so if you combine this particular term, you will get the result is as 30 into 60 C30. Now why do I need to make 60 C30? Because the value that we basically need to find out is given, and the answer is given as alpha times of 60 factorial divided by 30 factorial. And this idea or intuition comes only by practicing problems. This intuition comes only by practicing problems. So I would request you to practice as many problems as you can. In this today's discussion box, there will be a lot of problems present. Okay. So this will be 30 into 60 C30 multiplied with 30 by 60. Okay, 30 by 60. So if you look at this particular result will be nothing but it will give you 30 square, okay, into 60 factorial divided by 30 factorial into 30 factorial. Okay. So 60 by 30 factorial is present in the answer only, and the value of alpha is equal to, sorry, let me check the value of alpha. Okay, so that is, it is given as 30 factorial whole square. So the value of alpha, so we will not have to take this, we have to take the whole part. Okay, that is 60 factorial into 30 factorial ka whole square, and the value of alpha that will become is equal to 30 into 30. Okay, 30 into 30 by 60, 30 into 30 by 60. Okay, the 60 part is remaining. Okay, so if you look at this, it is 900 by 60, and we know the value of 900 by 60 is basically 9 by 60, which is equal to 15, which is equal to 15. So the answer to this particular problem is equal to 15. The answer to this particular problem is option number C, and that is basically 16, sorry, 15. Okay, the option number C, and that is equal to 15. Okay, so with this, I have covered almost everything that was basically needed to solve problems regarding binomial coefficient and a summation of it. Okay, I hope you will basically take this good advantage of particular lectures and you will come out solving this particular homework problem. Okay, so that is the only thing that I demand from all of you. Just solve this particular problems that I've given as you as a homework, and write me in the comment section that how are you able to understand this particular problem or not. Okay, and then only I will able to understand that whether you are getting this particular lectures or not, or how should I arrange or sequence my mathematics like courses. Okay, so that it will be beneficial for both of you as well as for me. Okay, so I hope this particular lecture was fruitful for all of you. If you have liked this particular lecture, please don't forget to like, and if you are enjoying this particular content and what kind of content I'm making, okay, instead of having my college works and my project works, as well as also I'm getting time to do this particular things. Okay, so if you appreciate my effort, please like the video, and if you are new to this particular channel, please subscribe. Okay, with this, I take a leave. Thank you.